Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at this AP Physics C mechanics problem. So let's get straight into it. An amusement park ride features a passenger compartment of mass m that is released from rest at point A as shown in the figure above and moves along the track to point E. The compartment is in free fall between points A and B, which are a distance 3r over 4 apart, then moves along the circular arc of radius r between points B and D. Assume the track is frictionless from point A to point D, and the dimensions of the passenger compartments are negligible compared to r. On a dot below that represents the passenger compartment, draw and label the forces that act on the passenger compartment when it is at point C, which is at an angle theta from point B. Alright guys, so when we're talking about the forces, we're going to have gravity, which goes straight down, and additionally we're going to have the normal force, which is going to be perpendicular to the plane. And since it's frictionless, these will be the only two forces that act on it. So, let's see. B says, in terms of theta and magnitudes of forces drawn in part A, determine an expression for the magnitude of the centripetal force acting on the compartment at point C. Alright, so we know that the centripetal force is going in the direction of N. So centripetal force is going in the direction of N because that's where the center of the circle is going to be. So it's going to be N. But also we have this component of gravity here. I'm going to draw it again. So we have gravity. We have N, but we also have this component of gravity which is acting in the opposite direction of N, this part right here, which is going to be the sine theta, considering this as theta. So that is working in the opposite direction because it's going this way, so it'll be N minus mg sine theta. And C asks us to find the expression for the speed as it approaches D. And so from here, we can just use our energy equation. So we know that it just starts with potential energy of 3/4 R plus this additional R here, which will give you 7/4 R. So we have mg times h, which is 7/4 R, and that is equal to the kinetic energy that it's going to have at the end, 1/2 mv squared. These m's will cancel. 7/4 rg is equal to 1/2 v squared. So 7/2 rg is going to be equal to v squared, so the square root of 7/2 rg is going to be your velocity at point D. A force acts on the compartment between points D and E and brings it to rest at point E. If the compartment is brought to rest by friction, calculate the numerical value of the coefficient of friction. So from here we're just going to use energy again. We know that the potential energy is going to be 7/4 mgr, and at this point it's all going to be dissipated into friction, which means there's going to be work done on it. We know, so all the energy is going to be turned into work. The equation for work is force times distance. The force is friction, and in this case our friction is going to be just normal force times mu, so mu mg. and the distance is going to be 3r. So there you have that. You can cancel out the r's, cancel out the m, cancel out the g, and you're left with 7/4 is equal to 3 mu. So mu is equal to 7/12. Alright, let's move on to the other parts of the problem. Now consider the case that there is no friction between the compartment and the track, but instead the compartment is brought to rest by a braking force negative kV, where k is a constant and v is a velocity. Express all algebraic answers to the following in terms of m, r, k, v, d, and fundamental constants. It asks us to write but do not solve a differential equation for velocity. So we have that ma is equal to negative kv, and we know that a is simply dv dt, so dv dt is going to be equal to negative kv over m. So there you have that. Now ask us to solve the differential equation. So we're going to rearrange the variables. We'll get dv over v is equal to negative k over m dt. We can integrate both sides. We will get that the natural log of v is equal to negative k over mt, and therefore velocity is equal to e to the power of negative k over mt. There you have that. There's your equation for velocity in terms of time. On the axis below, sketch a graph of the magnitude of acceleration. Alright, so the velocity begins at its maximum, and then as the velocity gets lower, the magnitude of acceleration is going to get lower, because the acceleration is proportional to the velocity. And since these both are constants, they don't really take apart. And since the velocity is going to be decreasing linearly, so is the acceleration. So it's just going to be a line like this. And there you have it. That's all I have for you guys today. That's how you would solve all of these problems. Thank you for watching. If you have any questions, comments, concerns, make sure to leave them in the comments below, and I will catch you guys next time.